log base 10. Those are what we called the
common logarithms.
Right. This is common logarithm. I had mentioned they are used for things like the Richter scale, measuring the magnitude of earthquakes. They're used in measuring sound, like decibels. Right? Okay. Don't worry. We don't really get too much into the application, but those of you moving into pre-calculus next year, you will then learn how to apply some of these things. Okay. Sometimes we just have to learn the basics of it, and then in the future, then you learn how to apply. Okay. All right. So we're going to learn a new number here. It is called E. Okay. This is called the natural base function. Okay. So on your calculators.
Wait, how do you get this number? Like, like you do your equation, sometimes you get the E.
So E it's kind of complicated to explain because it has to do with limits, something that you learn in calculus. If you go on your calculator, the lower left, you should see an E next to where it says 10 to the x power. So if I put an E to the first power, it actually has a value, okay? It's like pi. So that's what I put in here. So like pi and like square root of 2, E is what we call an irrational number, okay? And it's approximately 2.718. Just think 2.7, okay? A little smaller than 3. Okay, and it also has lots of applications, but first I just want to show you the natural logarithm is with a base of E. So picture that's a little 2.7 approximately, and we're going to abbreviate it with just ln of x. This stands for natural log of x. Okay, so
N is right there.
yeah, so this is natural log of x. So you just kind of imagine that there's a little invisible E in the subscript. Kind of like when we had just the common logarithm, we imagined there was just like a little 10.
Wait, there's.
What's that?
So what's natural log?
So remember, you can have a log with any base, right? Right. Let's say I had log base A of b equals x. We could change this to a to the x equals b. So imagine, what if I said natural log of a equals x? Now what would we write?
E over x.
E to the x would be equal to a. All right, because there's a little invisible E, little base becomes a big base. Okay.
Oh, wow. By the way, on my job, for chapter 7 and on, there's no solution. Any solution.
Oh, okay. I'll post them.
No, they're posted, but there's nothing.
Oh, yeah.
There, it's blank. It's what you're saying.
Yeah.
Okay. All right. So let's look at some properties. If I have e to the natural log of x, basically e and the natural log cancel each other out, and we're just left with
Is
x.
that an LN or
ln.
Alright, so what you mean by natural log?
Natural log.
Yeah, it is N.
If
It's
we-
like
What's the natural log of
phi
phi?
N.
It's L. It's an L.
It is.
Yes.
It's an ln. Natural log of e to the x.
Why don't they make it ML? What do you mean natural log? Oh yeah, wait, that's log natural.
Can you not hear?
Natural log means it has a base e, and e is about 2.7. Okay, so you asked me were you just asking Giddy what would be natural log of 5?
Yeah.
So imagine natural log of 5 is equal to x. So what does that mean? It means e to what power would give us 5? So if e is about 2.7, right, could we figure out? So we can find it looking at it exponentially, but if I just type in, so to get natural log, it's the control and then the e to the x button.
If you put E to X.
So I get about 1.6.
So that means
So that means e to the 1.6.
So two, like it's like that means like 2.7 to the 1.6 equals around 5.
Yeah. So 2.7 to the 1.6 is going to give us about 5.
So e to the 3.1 equals something.
But why is that a thing?
Well, we're going to get to the E is very important in population growth. Also, when we talk about, have we done anything in chemistry with like carbon-14 dating or anything like that? No. Half-life? Have you talked about half-life of a substance? Okay, so that's the application for this E. Now, so again, E is about 2.7. So we're saying 2.7 to what power gives us 23. So yesterday when we did these, we did log of both sides. I am going to take,
No, there is actually something special.
Yeah, we won't work circle.
No, it's like, isn't it when you bounce something back and forth, it'll like always equal like the digits of I, like a frictionless.
Oh yeah.
in a pendulum. Is that what you mean?
Give me a second.
Pendular range.
Okay, so whenever I have E in my equation, I'm going to take natural log instead of the common logarithm both sides because, look up here, natural log of E to the X is going to simplify to just give us X, right? These are going to cancel. So I'm just going to type into my calculator. Okay, we have our calculator handy.
It's 3.14 actually. If you want it.
Oh, you know what I just realized? We just wanted to write it in logarithmic form. So this,
Wait, so you're saying log E X?
wait, what?
Oh, like log equals base E. X.
How did you just get rid of
Because
it?
isn't ln log base E?
Log. So this,
Right.
so picture there's a little E here. So what happens is these cancel and I'm just left with X. So here,
Okay.
these cancel,
So you're just
and I'm just left.
with log X.
Okay? So here, we're just writing an exponential into logarithmic form, so we can leave this answer. And if we wanted to find the actual value, we could plug it into our calculator. Okay, what can we do with this one? We're going to take the natural log of E to the 4th equals natural log of X. Whatever we do to one side, we do to the other.
Wait, sorry.
So if you divide by
I'm confused what you mean. What I understand what E is. I just don't understand what natural log.
ln is just like the other one we did log n. Just put an ln. So, but it.
Right here. Natural log is a logarithm with a base of E or a base of about 2.7. So as soon as we write natural log,
That just means.
if I see natural log, that means it's a logarithm with a base E. So it's it's like a logarithm of about 2.7 as a base.
And they that was that like whatever.
But we don't want to put 2.7. We're going to use E because we're going to use E to evaluate these
Yeah,
expressions.
so then let's say there's the log 2.7. So like natural log something, like natural log 5.
It means 2.7 to something, right?
2.7 to something equals.
Right. So
whatever
that's what we're going to do when we get down here. Okay. What happens with the natural log and the E? They cancel. So I'm just going to be left with 4 equals natural log of X. Okay. We're just changing it from exponential to logarithmic. Yeah. So natural log of E is equal to 1. So what can we do with the powers? We can move the 4 to the front. And if natural log of E is equal to 1, that's how we just get 4 here. All right.
How do you get ln X from just that?
So I took the natural log of both sides.
Oh yeah, okay.
Okay? Just like yesterday we did the common log.
Can you like explain more how it works? I don't
Just keep going and you'll get on.
How what works?
Okay, ready? ln e to the 1.252 equals ln x.
Okay, so wait, we're changing from x logarithmic to exponential. What is the base here? So little e becomes big B for the base to the 1.2528. Oh, you did write that? Equals x.
And then you put it in that.
That's it. That's all you have to do.
Oh,
Oh, I think I know what happened.
I just
You
put
did
it-
that and then you did an extra step.
I know, I just put an L in.
Wait, could you do
Got
that again?
Well, let's try the next one. What's the base here?
Oh,
It's an
to
E.
the X equals
Yeah, just a minute,
25.
Mateo.
So wait. First. So that means ln 25 equals x. That's basically saying log 2.7 around. Let's just like say like around log base 2.7 or log 2.7 equals
So
25x or equals x or log 2.7 25 equals x.
Yeah.
Or x equals 25 equals x.
it means e to what power gives us 25. So 2.7 to some power is going to give us 25.
Okay.
All right. So how do I rewrite this in exponential form? It's going to be e to the x equals 25. We're not solving anything here. We're just rewriting it. Now we're
You could solve that in the calculator.
Yeah. Which that's what we're going to do.
Wait, Leon.
Eventually do. Mateo, you needed to see something?
No, that's what we make.
You got it? Okay. All right. We want to write each expression as a single logarithm. We've already done this before, just not with natural log. So the first thing that we want to do is move the exponents here. So we're going to write this as natural log of 1/2 to the third plus natural log of 6 squared.
Why do you do that?
So I'm trying to condense it into one. We've done this before with other logarithms. We just haven't done it with, but the rules are still the same. I want to be able to condense it into one logarithm. Now, can I simplify these two?
Yeah.
That's going to be natural log of, what's 1/2 to the third? 1/2 times 1/2 times 1/2.
When you say natural log of, that means that so like the right now this equation, the 1.8 is what it'll equal when you take the ln to something.
Right, right.
So
We're not worrying about that right now. We're just, but it's good to process that. What's 6 squared? Now,
right now,
I
ln
still
is
have-
the power of something equals
I have 2 logarithms here with a plus sign. Do you remember? What can I do to condense it into one? You remember? Addition can turn into multiplication. Subtraction turns into division. Okay, now 36 over 8. Well, we could divide the top and the bottom by 4. So we just get natural log of 9 over 2. So that is how we would simplify.
So that means that
You want a
ln
9
to
over
the
2.
power of something equals 9 over 2.
You want 9 over 2, you don't want like 4.5, right?
Yeah, just leave it 9 over 2. Okay, let's take care of the exponents first. There's only one of them.
Yes.
So it's going to be natural log of 3 squared minus natural log of 4 minus natural log of y.
So you combine it by doing ln 3 over 4 over y.
Okay, so natural, well, not, what's 3 squared?
9 over.
Now, anything with a subtraction, we get to move to the denominator. So since these are both minus, that means I'm dividing by both the 4
Times the power plus the power minus.
and the y.
You multiply it.
Yeah, because think about if I took
And then that's
a negative sign out. What if I took natural log of 9 and then I took out a negative? Do you see how I'm really subtracting these two multiplied together?
Yeah.
I like to just think if it's a subtraction sign, we're just putting it in the denominator.
and you multiply. Okay.
Cool. Okay, questions so far? 'Cause now we're going to solve. What I like about natural logarithms, they're actually can be a little bit easier than the common logarithm when we're solving. Okay. Okay.
Negative 2x.
Okay, first thing we want to do is we want to isolate e to the power.
So 3e.
Okay, so first thing I'm going to do, I'm going to subtract 4. Okay, so first part is kind of just like solving.
You have to move 3e to the denominator, no?
Yeah, I'm going to divide both sides by 3.
Wait, what? Why do you do that?
Well, what did I just write in
No,
the very
because
beginning?
It's to the power of a negative.
No. Okay, it's fine that it's a negative. We just need to
isolate.
isolate e to the power. Don't worry about the fact that it's a negative. Because do we know what x is equal to? No, I mean, x could be negative. Okay, now that I have that, once you do that, you're going to take natural log of both sides.
Then once you take the natural log of that e, the e will cancel out and just turn to negative 2x, right? So it'll just be negative 2x equals ln 2.
Good. Everybody okay with that? Remember we talked
And then
about.
you divide by negative 2, so then it's x equals ln 2 divided by negative 2.
Good.
Or
Okay,
x
take the
equals
left side.
negative.
You're just going to end up with a negative 2x. So after we take the natural log of both sides, you're just going to solve for x. Okay, so first step, isolate e to the power. Second step, take the natural log of both sides. Third step, we're going to solve for x.
So ln
Negative
e.
x equals.
Wait, so ln e is pretty much 1.
1. It is.
So the answer is x equals ln negative 1.
Well, now, what does it say? We're going to put it in our calculator. We're going to round. 10,000th place is 4 decimals. Okay, so on the calculator, let's,
Negative 0.3466.
what did,
Negative 0.363466.
oops.
I got negative 0.346574.
Yeah, around.
Yeah, so negative
1,000 is 4.
0.3466. Cool. And we should be able to, these are calculator okay questions. So if you plugged x back in to this side, we should get 10.
Can I try
Okay, so first thing, what do you want to do?
so we add 12 to each side.
Okay.
We get 3e4x equals 27.
Good.
Alright. Okay, now we need to isolate e, so we divide each side by 3. Which gives us e to the 4x equals 9.
All right. Now so we've isolated e to the power.
So now we need to take natural log out. We need to take natural log of both sides. So we do we do natural log, and we turned it into an exponent.
No. What happens with the natural log of?
Oh, wait, no, we don't. So we just do ln e 4x.
So that becomes just 4x because
they cancel.
good.
Equals ln 9, and ln 9 stays by 4. Yeah, those two cancel. So 4x equals natural log 9. Divide each side by 4. And then we, for x, we find out the decimal.
We get
0.5493.
0.5493. And there is a reason we're going to the 10,000th place. As you notice, a lot of these times the numbers are really small. Okay. All right. Questions? Okay, now we have a natural log. Now we're going to solve this way. Okay, first step. Now we want to isolate the natural log of whatever. Okay, so I'm going to divide by 2. So I have,
Whatever after the natural log is part of the natural.
okay. Step 2.
Take the natural log of 3.
Well, not the natural log. what do we want to do? We want to,
Oh, get X by
okay, we can do E to both sides, to the power of both sides. So it's kind of the opposite. So it's going to be like E to the natural log of 5x equals E to the third. So instead of now you could also write this in, well, hold on. We did something here. What happens with the E in the natural log? So we just get 5x.
Whenever there's an E and an ln, they just cancel.
Yeah, E and ln will always cancel each other. Right, and then so the last step here, we're going to divide by 5. And again,
Where's the E?
okay, E is bottom left next to the 10 to the x power. So E to the third divided by 5, we get 4.0171. Okay, how about B? Okay, so the first thing we're going to do, multiply both sides by 3. So we have natural log of x equals 6. Okay, now what? We're going to raise E to both sides. So E to the natural log of x. Well, the nice thing here, what happens on the left side? Yeah, we just get what? X. So we're just going to do E to the 6th power, which 403.4288. So if you want to get more decimals, remember how I said if you just go up, because it'll like give you more decimals that way. All right, I think this is the last concept here. And then, okay, remember that really crazy long formula? It was A equals P1 plus R over N to the NT. Okay, this was when it was compounded like monthly. So you would have N is equal to 12, or quarterly, N would be 12. This is a much, much more efficient way to figure out interest. Now we say this is continuously. So it's not just being compounded at the end of each month. It's like every single instant. Okay, this is where E is used. So this is
700E to 0.
Okay, so A equals PE to the RT. Some people just call it APERT, just to remember the order of the letters. So let's talk about what is A. A is the end amount.
No.
P is the principal amount. This is what we start with. R stands for rate. Make sure it's rate as a decimal. So if it's given in percentage, we have to move the decimal place over. And then T stands for the time. It's a much easier way to figure out interest. Yeah, what is your, okay, so we deposit 700, that's our principal.
Wait. Does the equation end up looking like A equals 700 E to the power of...
Yeah, let's see, 700 E to the 0.03 times 8. Let your calculator do the work. All I need to see if this was a quiz or a test is just the setup. So I'm just going to do 700 E, bottom left, 2/3 of the way down. It automatically makes it an exponent because it knows you're probably going to raise E to a power.
889.874.
Yeah, so since it's money, let's just round to the nearest cent. So 889.87. So as you can see, if you have $700, 3% interest over 8 years, you've made how much? $190? Not great.
I got 1327. Wow, I But in the
That
same
sounds
way,
like a scam.
Well, you're still making money.
In this case, there's like no math in this.
Right, it's just knowing how to use the formula. Oh, you did 0.8 and what's that?
We should invest ahead.
Ooh, we should see how we can invest and make some good profit here. Okay, so the next question. How long will it take to get 1,200? So this time I'm...
I did the same.
No, you didn't.
But
You
that
did
was-
0.08 instead
That
of
makes
0.03.
that makes it so it's
3.
Yeah, 3% interest. 8%.
Okay, so I'm still starting with my 700 amount. But this time it says how long. Okay, so we just did this. So the first step is we need to isolate e to the power. So I'm going to divide both sides by. So that's just going to give us 12/7. Probably. But it's just that APERT formula. Okay, next step. We want to take natural log of both sides. So natural.
Oh, so you should.
So natural log. Now the left side, there's nothing I could do with that. But the right side, I'm going to end up with 0.03t.
And then you should divide by 0.0.
Perfect.
So just in each of these, one of the variables we're missing. We just find that.
Exactly. Exactly. So we're going to take this. Now I'm going to guess this is going to take a pretty long time here. Because if it took 8 years to reach 889, you got 18 years. Whew. That's a long time to make that much money. So is this a good investment of 3%? No.
Only get $1,200.
Yeah. Now, if you're talking millions of dollars, maybe 3%. Not bad. Right? So we'll say it's about, did I say what to round to? No.
The 3% is $30.
If it's 7.9, then just.
So we'll say about 18 years. That's a 7, by the way. So. Okay, last one here.
What's like a good investment that you can do? Something that still slow, but it's like guaranteed to go up.
I mean, 3% actually isn't bad if you're guaranteed. It's just, it's hard to find those kind, you know, if you want to make like 7%, then it's going to be more risky.
For my apartment, so UKP is really bonds for some reason. Those
And-
like 1% flat out.
I have no idea.
Oh yeah, I know that.
What?
I also got those.
Yeah.
I got $100, and my parents never gave me.
I got like $4 and it'll be $48.
I had to buy my own computer for school.
Ooh, that's not a very good investment
No,
then.
it's not.
No, I'm sorry.
You guys should invest in the Congo that make the Congo fresh.
My uncle gave me $1,000 in cryptocurrency. It's now worth $3.
Yep, crypto's not the best investment these days either. Okay,
You know, maybe, you know, Giddy reminded me something. Maybe it's because you got a car on your
oof. Okay.
I think that's why the investment is so fun.
All right, how much would have to be deposited? So this time, we're trying to find out what the principal amount. So what if you want to make to get an amount of 1,500 after 12 years? And we're still using the 0.03. Okay, so every single time you're going to have every variable except one that you were solving for. So I have 1,500 PE to the 0.03 times 12. What do you think? What are we solving for? P. So I'm just going to divide both sides by E. Now I could make that 3.6, E to the 3.6 if you want, but, or we can leave it. I'm just going to use the calculator to type it all in now. Oops. So 1,000. So that means I need to invest this amount to get $1,500 after 12 years. So you can also look at, right? Like if you need a certain amount by the end of this many years, how much do you have to invest? Again, 3% shows us doesn't really get us much. So if you want a higher rate of return, that's what I was talking about. Then it's a little bit riskier.
I have a question.
Yeah.